Hope everybody is doing great today. I'm just going to begin regarding my topic for today, that is sound design fundamentals. So we are going to, thank you. So first things first, what is a sound system? So a sound reinforcement system would be a combination of microphones, signal processors, amplifiers, loudspeakers, and enclosures, right? Like based on different applications, you would need all of this gear. And also the main reason why you use them is because it makes the live or pre-recorded sounds louder, and it also helps us to distribute the sound to a larger or more distant audience. For example, it could be a chapel, it could be an auditorium, it could be a gymnasium, it could be a banquet hall, right? So depending on the space, you need audio system equipment for dispersion of sound throughout the space evenly. So whenever we plan to design a system, there are a few key things that one must think of before proceeding. A few of the most important points will be discussed now. The first one is, where is the system going to be used, right? So either the system is going to be used indoors or either the system is going to be used outdoors, right? If they are going to be used in an outdoor environment, it's highly recommended to go for weather-resistant speakers, right? Because the temperatures can drop low, there could be rain, there could be snow, so you don't want to install a gear and then it goes bad, let's say in a couple of days, weeks or months, and then you have to, go back and worry about it, right? And secondly, if it's not an outdoor, definitely it's an indoor. So when considering an indoor environment, it could be, like I said, it could be a chapel, it could be an auditorium, a gymnasium, a retail store, or anything of that sort. And you need to be careful with the reverberance, right? So usually what happens is you design a system, let's say, we design a system for a banquet hall. We go to the site, we think, okay, this is the space, this is the height, the length, width, height of the room. And we do our calculation and we install certain speakers. What we usually tend to forget is the reverberance of the room, as to how the room sounds when there is, when there's no audience in the banquet. But when there are a lot of people in the room, the output will definitely be different. So you have to be very careful when designing such spaces. You have to make sure that you take the reverberance in the space. And moreover, not all spaces that you will be designing will be acoustically treated. There are always going to be acoustic anomalies, right? Not every space that we go to design will have a carpet flooring or will have acoustic panels, right? Like we see in installations for mosques and churches where they use highly reflective surfaces, which poses as a challenge. So you have to note all of that before you proceed with the design. Second most important point would be, what is the system being used for, right? If it's for background music, let's say it's a Tim Hortons or any store, any clothing store inside the mall, or any other application, right? In that case, it's just background music. Customers come to shop, they want to have a nice ambiance, so they play some music. So that's background music playing, at the background. Or it could be foreground music, or it could be paging. For example, in a school, where the principal wants to page to individual classrooms, or to the corridors, or to specific zones, right? So you have to kind of narrow it down as to what is the requirement or what the system is going to be used for, okay? And then try to understand the expectation from the client end with regards to the quality of the sound. Do they need high fidelity? Do they need speakers which are, high end, which are, probably with like the coaxial speakers with passive crossovers and stuff like that? Or they need basic full range speakers and basic, entry level stuff, so that, if they have a tight budget and they want to, do a lot in that limited budget. So that's something that needs to be narrowed down beforehand, right? So discuss that, with the client as to what they need. Also, a lot of people say that, okay, it's a lounge maybe or a restaurant, right? So it's important to actually see bass, right, like a thumping sound. So then woofer, that needs to come into consideration as well. But when it comes to speech or paging, we also need to be careful what level of intelligibility is expected. Now, basically, intelligibility is something where, the sound, we go by the 3 dB rule. So let's say if it's a gym, or if it's a hockey arena or something like that, we don't want the sound, like you sit in certain areas and you get clear sound, and let's say you're sitting 20 feet away, right? You are sitting in the backside and you hear nothing, or maybe the sound is too loud. So we have to make sure that we design the system in such a way that the sound should, not vary much, and it should sound even throughout the space, okay? Coming to the next point, how loud the system will be. Like I said, it depends on the actual conditions of the room. That would be background noise level. For example, let's say it's a hallway, right? So we know that there's going to be a lot of people in there, so the ambient noise level is going to be high. So you have to make sure the speakers are, loud enough so that when an emergency paging or any announcement is made, it's audible. Or like an airport, right? There are thousands of people moving across the airport, and if there is lost luggage, or if there's some emergency announcement, the volume or the output has to be loud enough for everybody to hear. That's very, very important, right? And also if the system is used for foreground material, right? Number 4, once you know what the client wants, once you know what their budget is, once you know what kind of, speakers they want, whether they are high fidelity, whether they are low fidelity, or they want general purpose speakers, right? So then you need to, start working as to where and what kind of speakers you plan to use. Are they wall mount speakers, or are they ceiling speakers, or are they going to be suspended? And based on that, you will have to kind of decode what kind of brackets you're going to need. And if there's a subwoofer in the place, then you need to, decide how the cabling will go and where you plan to put this up. Now the next point is, what will the speaker spacing be? Depending on the standard speaker layout patterns, that is a square or a hexagonal staggered. So after selecting a pattern, you have to make, try to understand what performance or how the level is going to be between the speakers, right? And after the speaker spacing, the most important part is the amplifier power and the wiring, right? So if you're using a speaker which is, let's say, 30 watts each, and you got, let's say, 8 of those, so roughly around 240 watts plus, you're going to use that many speakers, right? So the amplification part is very, very important, because that is what is going to drive the speakers and give you output, right? So you have to make sure you always, by rule of thumb, is what we usually prefer is 20%. We leave a margin of 20%. So you shouldn't try to keep a buffer, right? So if you have 240 watts of speakers, right, in totality, you should have a safe margin of amplification. Don't just go with the 240 watt amplifier with a 240 watt speaker, right? So it's better to always keep 20% more. In this case, it would be roughly 40%. Go for a 300 watt amplifier for 240 watt speakers, right? Also, if you're using them in 70 volt, then you need to calculate the tap that you are tapping them at. Let's say you've got 10 horn speakers, which are capable of delivering 30 watts, 15 watts, 7.5 watts, 3.8 watts taps, right? So you need to kind of calculate that as well. Based on all these calculations, right, and that when I say calculation, I mean the wattage calculation, you have to determine how far the run is going to be. Like if it's a warehouse, right, you have, let's say, 30 horn speakers. So your head end is in one unit. When I say head end, your amplifier, your processor, your keypad, all of that is in one place. And the farthest point of your horn speaker will be, let's say, 450 feet. So you have to make sure you use a very thick speaker gauge, pure copper speaker gauge, roughly around 12 to 14 gauge speaker cables, so that you avoid the losses, right? And you get good optimum sound throughout the warehouse. This is just a particular example that I'm giving. So wiring gauge is also very, very important. There is a slide that I've included, I think it's going to come next or next, where there's a chart of speaker distance to the gauge of the wire. So we'll discuss that when it comes. Also, the most important part is for the client, for us to know whether the client needs a very high-end audio system, which is precise, which is accurate, which sounds very good. So all this can be done when we look at the minuscule details of sound processing or signal processing. So like most of you must be aware that we have our 9000 M2 series which have frequency correction, which have a lot of EQing functions, compressions, and all of those, which will help and enable the installer to fine-tune the system. So if you fine-tune the system really, really well, the output is going to sound that good, right? Which ultimately helps you achieve the goal of giving the client what he needs, right? Also, there has to be muting capabilities, right? So you have to get a list as to what all the client needs. Let's say, for example, there is background music going on, right, in a store environment, and let's say there's an emergency page. And when the receptionist or the person at the desk lifts his or her phone and gives a page, the system should be capable enough to cut down the background music and get in the page since it's an emergency, right? So muting capabilities, right, for BGM and paging, all of those are also very, very important when you are designing a system. Also, signal leveling and compression, can be used to maintain a volume level up and down and prevent excessive damaging signal levels. So yes, our 9000 M2, D901, D2008 signal processors are all capable of doing all of these functionalities. Okay, and now coming to one of the most simple topics, but also very challenging when it comes to designing, is the amplifier zone. A lot of time customers have different zones, right? So they might say, okay, I want the office area to be one zone, I want the outdoor area to be another zone, I want the warehouse to be another zone, and you have multiple zones. So then you have to break up, break apart the total area, try to understand what kind of speaker will fit in a particular zone, and then calculate the wattage accordingly, and then decide the amplifier output wattage that you need for that particular speaker zone. Also, if it's multi-zone, then you have to go with multi-channel mixed amplifiers like the TOA M9000 M2, backed up by the DA series amplifier, our DA250, DA500 lineup. Also, the next topic would be what type of sound sources. Now, the most important thing is whenever you have a setup for audio system environment, inputs, right? So, like microphone inputs for paging. So for example, we use the TM660. At times, people want to use the telephone paging. So we suggest them using the ZP001C module or the XP11 exchange. At times, for background music, people want to use DVD players, CD players, FM tuners, and all of that. And at times, customers also want pre-recorded messages, right, which needs to be triggered when there is contact closure. For example, if there's an emergency and there's a pre-recorded message which says, kindly exit the space, immediately there's an emergency, right? That's a pre-recorded message. So whenever the contacts get closed, the background music will fade out, and this emergency page, which is a pre-recorded digital message, will start playing so that everybody in the retail environment can safely exit. Then we have different modules that can go in the system. Also, we have send and receive capabilities. Then we have, we can control from fire alarm panels with regards to the muting of the audio system. So basically, just to make it simple, we need to understand what the client needs first. Second, then derive what kind of speakers, what kind of zones, and what kind of amplification, and whether or not they need processing. Do they need emergency announcements? Then do they need background music? And just to get an information and insight as to what will the client need firsthand. Now, coming to the next interesting topic would be speakers. So based on your coverage, right, what area you want to cover. Now, for example, this boardroom, right, I'm not going to get two 18-inch stops with, 18-inch stops. I don't need that for this space. So it's important to understand what kind of speaker will fit into what type of environment, right? So if it's a lounge, then that kind of setup would be ideal, where you can use our line arrays, where you can use, our subwoofers 12 inches, 15 inches, or even if it's a gymnasium, right? Otherwise, if it's a small retail environment, we can go for wall mount speakers, just so that there's enough sound, like background music, which is audible enough, sounds good, and adds to the ambiance. So the most important specs to know with regards to the speaker is the SPL output and the dispersion. So the dB level, right? So what dB level are you getting? Usually, while designing the system, we go with different brands, and we go by, okay, on that side we saw an X model of the speaker from an, X company. So that should be pretty good because it sounded good there. But the interesting fact remains that we need to go through the specification of that particular speaker, right? What dB level you're getting in a square meter space, right? So in 1 meter you might get, if it's a 1 meter area, you should be getting, let's say, 135 dB, or 129 dB in 2 meters, or 123 dB in 4 meters. And what is the dispersion? The horizontal and the vertical dispersion. It could be 60 horizontal and 40 vertical, right? So the specifications are always mentioned in the specification sheet. So it's important to go, glance through it once, just walk through it once. If you're planning to use any particular type of speaker, just go through the specification once so you can determine, okay, whether or not will it work in a particular environment, right? Also, the sound pressure level of a speaker will determine how loud a speaker is at a given distance. That's what I mentioned, just 135 dB per meter or 129 dB per 2 meters. That's the example we have in place. Dispersion is, like I described, is the way the sound is projected horizontally or vertically from the speakers. The higher the speaker, the farther the sound will travel, right? So the height at which you install the speaker is also very, very important. We see a lot of customer calls where, the recommended height after the design is 7 feet and they install it at 9.5 feet, and then they're like, oh, it sounds muddy, it doesn't sound right. Because the farther it goes, you have to open up the volume even more, and it's going to, not sound right. So the placement of the speaker is very, very important as well. Now, the type of speakers, one of the most popular ones is the dynamic type, which we often use. So the principle is similar to that of dynamic microphone, and the principle, to make it very, very easy, is similar to like how our ears are, right, our ears. So when a varying electrical signal, that's the current, is channeled through a movable coil, that's a voice coil. So it's like basically whenever someone talks to you, right, there is a signal, which goes through your ear, right, and that is then processed, and then you listen to it, right? So so when a varying electrical signal is channeled through a movable coil surrounded by a magnet, the coil moves back and forth. It causes reverberation, right? So the cone, mostly used of paper, is attached to the moving coil that produces variation in the air pressure. The air pressure, that is sound waves that correspond to the electrical signal driven through the speaker coil. So it's basically a transducer. It converts one form of energy into, the other form of energy, that is sound waves. The next interesting topic is speaker processes. So basically there are two types of speaker processes. One is passive, one is active. So speaker processes combine the number of processors racked into, rack mount signal processor like gain, EQ, delay, crossovers, limiters for input and output, a lot of functionality, for example, automatic resonance control, ARC, etc., etc. And also a typical processor might have stereo input. It has multiple outputs, usually 6 outputs in the case of MX64D. So to save time, money ahead, allows you to fine-tune or provide fine adjustments to optimize the sound quality and reduce feedback. So it is always recommended that whenever you have speakers that are going to the amplifier or to a media source, always have speaker processors like mixers so you can, do the fine-tuning before it goes to the amplifier. Excuse me. The most important part is the amp, that is the hardware system, which, takes the sound you put into it and makes it powerful enough. So it amplifies, as the word says, it boosts the power to the speakers, right? So whenever you design a system, like I said in my previous slide, it's very important to calculate the amplification part of it. So, let's say we have two speakers, right, which are 8 ohms, which can handle 250 watts, right? The amp will feed at 4 ohms, right? So we make sure that, the amplifier can at least handle 500 watts. In the case that I mentioned, we should always have a safety margin of, let's say, 20%. So it's always safe that, your speakers don't get damaged, your amplifier doesn't get damaged. Okay, audio amplifier have 3 types of classifications. So this is where it's going to get a bit tricky. Anyways, so first is preamplifier. So what is a preamplifier? We also refer it to be as preamp. We call it preamp. Basically, it's an electronic device that amplifies a very weak signal, like from example from a microphone, and it makes it strong enough to manipulate the output, right? So preamplifiers are often simple fixed gain amplifiers designed specifically for low noise performance, right? Because you have line level inputs like microphones and others. Now, second is low power mixer amplifiers. Consider a small environment where you just need a couple of speakers, just one DVD player, right? So you're not going to have, the client obviously wouldn't want to spend a ton of money on signal processing and, keypads and, automatic resonance control, all those features. So basically, you can use a low power mixer amplifier which has inputs, right? It has basic EQing capabilities into one package. So you can just connect the speakers that you want to use at the back, right, at the speaker output of the amplifier. So basically, it's fixed gain amplifiers. They are designed specifically for low noise performance in a small scale application. Now the next is power amplifiers. So all you see in power amplifiers is their main goal is to boost or increase the signal power so as to deliver or drive a load, to the output speakers. So similar to preamp, power amps are often fixed gain in terms of signal amplitude, in terms of the functionality, so that the designers can focus on high power gain. So if it's a gymnasium, right, you need line arrays. If it's a hockey stadium, you need line arrays. And these line arrays, have high output power capabilities up to, like roughly around 750 watts. So you need power amplifiers to drive those kind of speakers, to drive those kind of drivers, right, and to give you that humongous output that you need for such a large space. So in that case, you would want to use power amplifiers. So we have our own very efficient TOA DA series lineup. That's the TOA DA250 and the 500 lineup. Now, the most interesting concept of speaker impedances is 8 ohm versus 70 volts. Usually, while talking to clients or while talking to installers or talking to designers, we hear the term low impedance, high impedance, or 8 ohms or 70 volts. So 8 ohm is considered to be low impedance, and 70, actually this is 70.7 volts, not the 70, 70.7 volts is considered to be high impedance. So where is the 8 ohm speaker used? Usually it is used where we need, the best fidelity, where you need good bass, and budget is usually not a constraint, and you need a more expensive or high-end system, right? You may need to calculate the aggregate impedance of the speaker per channel to make sure they fall within the range of the amplifier. So this often creates a need to wire speakers in combination of series or parallel to fall within their appropriate range, because you have to manage the impedance of the speakers, right? Also, it will be limited in the total number of speakers per channel, so as well as speaker cable lengths to be observed. Speaker cable length is a very important thing which is often neglected. People spend a ton of money on speakers, people spend a ton of money on processing, people spend a ton of money on amplification, and a lot of times it happens they ignore the speaker gauge and they ignore the length that the cable has to carry to successfully output from the speakers. So that is also very, very important. For better option for concerts, for places of worship, for arenas, for gymnasium, usually everybody wants to go ahead with a low impedance, that is an 8 ohm system. Now 70 volt system is usually cost-effective alternate to the much more expensive 8 ohm or low impedance system. And the wiring is pretty simple. You don't have any confusion of series or paralleling speakers, right? And it can be easily expanded. So let's say you have a school which has 9 classrooms, right? So how are you going to do series parallel in 9 classrooms? So what you do is you have 70 volt speakers in these 9 classrooms, right? And these 9 classrooms will have those
the traditional yeah, but it's not only the.
Sorry, I was interference. Yeah, so like a classroom with nine classrooms having 70 volt speakers, right? So you can easily add.
Any reason
let's say there's a class of two more classrooms, so you can add 2 more speakers, right? And it's easily expandable.
Voice,
right?
And any audio.
Then the next is different areas can have different sound pressure levels that you are using a single amplifier, right? It's the best option when it comes to a distributed system. Now, 8 ohm versus 70 volt, 8 ohm parallel connection, right? So when you have an amplifier and when you have 2 speakers, right, each having 8 ohms, so when you connect 2 8 ohms in parallel connection, it's going to be, 8 ohms divided by 2, you're going to get 4 ohms. So you're going to divide that into parallel load. So you have to make sure either you can connect them in series or in parallel, but you have to match the impedance, for the output channel of the amplifier. Load becomes 4 ohm to the amplifier just by having 2 parallel speakers in parallel. Unable to add more speakers unless using an impedance matching device like a speaker selector or a volume control. High impedance speakers, like you can see, let's assume this is a classroom environment where you have a high classroom. Each speaker having 70 volt speakers, right? So you can tap them at 1 watt each. So 5 speakers, each having 1 watt, so 5 watts. There you go. That you can have 5 speakers. You don't need to do series parallel, nothing like that. And you can use as many as you want, right? I have a message. Hold on for a second. Yes, I was about to say that. I would request everyone to kind of mute their microphones so there's no interference during the webinar, and there will be a Q&A session as mentioned by Nelson in the end. So I would appreciate if you guys could just put your microphones to mute. And continuing further, I've explained the advantages of 70 volt and the advantages of 8 ohm system. Now, a typical 70-volt system is like this, right? So there is no restriction when it comes to series or paralleling them. So there are different speakers spread across different environment, like a school maybe, or like a retail environment where you have 70-volt speakers and they all come up to one spot and you can connect them to the 70-volt output line.
Much can hear.
Right. Now, 8 ohm versus 70 volt when it comes to frequency response, right? So frequency response is an important speaker characteristic. It represents the frequency range over which a speaker can successfully propagate sound waves.
Feedback.
So speakers can be categorized mainly into three categories.
Before, only have one brand do like those things, but right now it's an analog equipment. Before, right now digital always goes to the filter one.
So yeah, so we have the tweeter, that's a dedicated speaker, right? You get the highs or the HF, the tones that you get. That's the tweeter that handles above the frequency above the mid-range, right? So all the treble or the drum snares and all that you hear is from the tweeter. Mid-range is typically from 500 hertz to 300 hertz. Usually the vocal that you get, the speech that you get is mainly into that frequency band. And bass, right? A lot of people, when you hit the drum bass, you get the pumping sound. All of those electro dance music, you have the low ends. They are all dispersed by the woofers, right? So they are typically below 200 hertz, right? So 20 hertz to 20 kilohertz. That's the entire frequency spectrum. So each covered by the tweeter, the mid-range, and the woofers. Now this is what I was talking about. This is the sound standard engineering data that we have here. So like you can see, if you're using the system, let's say in 70 volt, right, and if you're using a speaker gauge of 18 AWG, with a load of 100 watts, the maximum distance you can travel is somewhere around 230 feet only. So like I said, I gave a particular example of a warehouse. Because it's a very big space. So if you have a big, huge warehouse where you're planning to have more than 100 watts, and you say, okay, I'm going to buy the best amplifier, I'm going to buy the best speaker, I'm going to buy the best head-end equipment, and if you ignore the cable, system's going to suffer, right? Because the 18-gauge cable can only go maximum up to 230 feet if you have a 100 watt load. So that's what this is the speaker chart. If you want, you could request this, and we can send this to you, or I can request Nelson to provide this to you guys in case if you need it. Comes in really handy when you want to calculate the distance. Most important point, what is reverberation? So basically, reverberation sound is a collection of all the reflected sounds in a facility like an auditorium or a boardroom in this case, right? So reverberant sound is the collection of all the reflected stuff. Because like in this particular boardroom, we don't have any acoustic treatments. We just have basic walls and basic things. So there is some amount of reverberance that you can hear even in the conference session that we're having now. But when you go to a theater to watch a movie, it's very silent. Why? Because there are sound absorbing materials and acoustic treatment done. So reverberance is a very, very tricky topic when it comes to designing a system, because it greatly affects the output, right? So it is very, very counterproductive with regards to intelligibility is required, right? Such as in a speech of a live play. We often do not hear speeches or announcements clearly at churches, gymnasiums, stadiums, or factories, or in a warehouse. So, for example, you went to the chapel on Sunday morning, and when there's an announcement made, or when anything is read or said, we often wonder, did I not hear it correctly, or what did the gentleman just say? This is because there's a lot of reverberation in the room, and the system is not finely tuned, right? This happens because the original sound is interfered by its reflected sound. So when a sound is emitted, right, from the speaker, right, it just doesn't come to you directly, right? There are different reflective surfaces which the sound hits and then comes to you from different angles, from different spaces. So at times, it will interfere by its reflected sound and noise. So the most important thing is how to reduce reverberation and how to increase intelligibility. So to minimize the reflected sound and noise, the architectural design stage is by adopting the sound absorption and isolation materials in walls, ceilings, and other areas, basically to have an acoustic treatment. If it can be done at the architectural design stage, there's nothing like it. It's peace of mind for the installer because he or she is confident and sure that when the actual install is done, it's going to sound great. Also, we have to be careful the way, if it's a huge setup like a gymnasium, right, or if it's a arena or a theater or an auditorium, you position the line speakers, which are characterized by high level of directionality. So we have line speakers which you can suspend at a particular height. You can tilt each one of the arrays at a particular angle, just to make sure you have high level of directionality and the ability to transmit sound energy directly with little attenuation over long distances, right? So when the speakers are facing your listeners, it gives them a clear understanding of what's going on, in this case, the auditorium, right? They should be able to clearly listen to what the dialogues are going on stage, right? So yeah, also, you can use TOA's reliable mixers because we have ARC functions, which enhance sound clarity because it has automatic resonance control feature. ARC is automatic resonance control. So it basically tries to control the resonance or the reverberation that's taking place in an environment, right? So it almost becomes mandatory to use a digital mixer or processor which can suppress the reverberation or resonance. So yes, then you need to have all the bells and whistles with regards to speaker amplification, processing, and all of that when it comes to high-end projects like auditoriums and gymnasiums. Yes, so now we'll be talking about some application examples. Common challenges in retail, right? So if it's a smaller space, the small challenge that everybody faces is the effective coverage. Because it's a smaller space, you don't want to spend a ton of money. You don't want to suspend speakers everywhere you look, right? You enter the space and all you see is speakers, speakers, speakers. The client doesn't want that. The customer doesn't want it. So you have to be careful while designing a small retail space to give maximum dispersion, to give maximum intelligibility using, fewer speakers. When it comes to medium to large spaces, either you have high ceiling, right, like retail stores like IKEA, Walmart. All right, so when the ceiling is very high, right, or it's variable, you have a distance factor, right, because the speakers up high, let's say at 14 feet, and you're, on ground level, your hearing level is, let's say 5.5 feet. That's definitely not going to sound right. So that also needs to be taken into consideration. Also, architectural obstacles, right? So recessed area. At some areas you'll find outlying areas like stock rooms, fitting rooms. Then you have a lot of glass. You have a lot of tiles and reflective surfaces. So based on site, I personally, whenever get a chance to work on site, I would make a note of all these factors that would affect my design. And also, we have human mind, right? We have tens and thousands of things over our head. So always take permission and take pictures of the site. So when you are in your office doing the math, doing the calculation, you can look up the pictures, relive the site visit, right? So okay, here there was glass. Okay, here this was a reflective surface. Oh, here it was a very high ceiling. So taking pictures, writing down the dimensions of the room, all of that, making small notes always help when you sit to design a system or any particular project. Now, application examples, right? So if we have a tiled ceiling, we can, distribute the audio with ceiling mount speakers, right? So you suspend them, so the speakers right above your head, it's going to, disperse the sound above you. So we have speakers placed in the hallways, in the corridors, in restrooms, and all of those. At times, the ceiling, maybe it's an open ceiling concept, right? And we have to install wall mount speakers, right? So we kind of have a local distribution, like we are firing speakers from both directions, right? It could be a car dealership, for example, where you're sitting in the waiting lounge and the TV, and then there are two speakers, right? They're just firing at you. So it could be a ceiling application, it could be a wall mount application. Now, common challenges. This is one of the most interesting and challenging things we installers, we designers come across. It's also very important to know knowledge-wise, So whenever we go to a space, it's either filled with people or partially filled with people, or it's empty. So the space remains the same, but the anomalies will change, with the audience. If it's totally empty, it will be different. If it's filled with people, it will be different, right? So for medium to large spaces, a challenge would be a hard surface, a reverberant environment, distance to rear. Like if it's a chapel, if you have a dome, right? It's definitely going to create a lot of reverb. Then architectural obstacles, right? You feel, okay, I want to install the speaker here, but then the architects say, no, we have a column that we're going to have some, beautiful carving coming on top, or some design on it. You cannot put your speakers here. Then you have to work your way through, okay, if not here, then where to install the speaker, right? Causing minimum reverberance, causing maximum intelligibility, right? Then you're in a game, you're in a basketball game or a hockey game, right? So you see a center cluster of line arrays firing towards, all the four sides, but you're sitting in the bleachers, and there's something being said, but you cannot hear it, right? So that's important. Intelligibility for the bleachers is important, right? Then at times, you go to a birthday party or a wedding or a function or a ceremony where someone is trying to talk, right? So now I'm a pretty loud talker. Someone might be a very soft talker. You're not able to hear what they're saying. So you crank up the microphone level, and you're able to hear them. So that level adjustment, the fine tuning is also very important. But also, the moment that person goes away and somebody comes in his or her space, right, and starts talking very loud, you will immediately hear a very annoying sound called as the feedback. So controlling of equipment to make sure that the levels are set right is also a very big challenge. And at times, you have high background noise, some noise going on around the back. It could be of the traffic, or it could be of some construction going on, or something else. Also, you have to be careful to, cater to the hearing impaired, because you have people in the crowd. Also, whether you're sitting or standing, because your listening level, hearing level changes. Because when you're sitting, it's roughly around 3.5 feet. When you're standing, like the way I am, it would be roughly around 5.5 feet. So your listening levels on an average also is very important. Now, coming to the point speaker distribution, if you can look at the image, the green imagery that you can see. So for front wall, both sides, right? So you have a chapel, you have, the prayer area in the middle, and then you fire off left and right two speakers directly into the audience, right? So it could be for a small room, it could be for a big room. Then there is something called a floor cluster. Spaces with high ceilings, right? So you go to a lounge, right? And they have high ceilings and dark black ceilings with, nice decor, nice ambience. So you suspend the speaker in all the directions, firing in all the directions, right? To get even sound everywhere. Also, then you have distributed sidewalls like columns. So you walk through a particular space and you have speakers firing from both directions at even distances. Then one of the most important type design areas. So when you go to watch theater or live shows, you see there is a huge stage, and just ahead of the stage there will be line areas to your left and to your right, and that's like a cluster of line arrays. And in certain spaces, you will see a center cluster, a single cluster of line arrays, just, each of them tilted at a particular angle to cover the entire area. So this was the one I was talking about, the cluster design. So yeah, you rig it in the center and, install the speakers in north, south, east, west, the 4 directions example. So you will have 92 dB at 1 watt, 86 dB at 4 watts, so on and so forth. And as the distance increases, your SPL level, kind of goes down. But you have to make sure that it sounds even in the overall space. Like the example that I gave you was that of a restaurant or lounge, where it shouldn't be that, okay, I want to sit at this particular spot because it sounds right. And the moment you go to the other space, oh my God, it's horrible, it's too loud. Or when you sit at some particular space, you feel, oh, I cannot hear the music, right? So it has to be even. So there should be a sweet spot as much as you can deliver to the end customer. It should sound right, it should sound even throughout the space. Speaker distribution, you have different options, right? You have different accessories which help you to install the speakers. It could be, installed on walls. We have wall mount brackets. At times there is no flat surface. You have a column, like a round column. So you have a column mount bracket where you can suspend the speakers, right? And you have the image representation in the slide. Now this is a classic example of even speaker dispersion, right? One of the things that I learned in being into audio since so many years is that a lot of time installers, they put speakers at far, like farther more apart. They are apart from each other at even more distant than they're supposed to be. So when you have two speakers, the people who are very close to the speaker will find it to be very, very loud, right? Because you are trying that the audio should reach the last row or the last person sitting on the bench or the aisle or whatever it is. So it's better to divide the number of speakers that you put in this case. So it gives you an even distribution of sound, right? So instead of tapping two speakers at 30 watts, right? And it will travel farther, right? So the person sitting at maybe, let's say, 30, 40 feet will be able to hear. But imagine what the condition of the person will be who's just below the speaker. It's going to be very, very loud for that person. So it's better to tap it at, let's say, 7.5 watts or 15 watts and then go a little bit more ahead and then, distribute the sound evenly. But in this case, there is no central point of focus for the sound source. Houses of worship, we have SR, S4s, slim line arrays. They sound excellent mid-frequency high-frequency response. We have ton of wireless microphone systems, both handheld, lavalier, headset. We have digital speaker processing using our MX64 mixer and the DPSP3. And then we can use our F series lineup for our fillers. Let's say there's a balcony area, or there's an extreme back area, or there's a attached banquet, or a small, meeting room or something like that. So yeah. Common challenges of sports facilities. A lot of installers find, the challenges when they're designing a system. Most important again is reverberant space. Second is need to cover all areas, all or partial or combination. Third is adaptability for different setups. There's enough power for big crowds. Fourth is controllability, right? So it's whether you want to have this one zone or different zones, thank you, or you want the content input for different setup, right? So these are the common challenges that one faces when designing a sports facility. Speaker output for distribution, we have excellent linear speakers, that is SX5s and SX7s. They are, direct the sound to the areas you want and have less wall reflection. You have the option of tilting each of the arrays to 0 degree, 15, 30, 45, 60 degrees, right? And they have a horizontal dispersion of 100 degrees. So you can highly, control the way you can disperse these speakers, and they sound excellent. not to mention that, they look good too as well, right? So that they are linear speakers. Here you can see few of the images where, the linears have been installed. Also, speaker options to adapt to location. So based on the site visit, you decide what should be the coverage of areas, right? So whether you want to cover all areas with one set of speakers, or you want to divide it, or you want to do it partially, or combinations. Also, zoning. You need different zones. Different zones may require different kinds of speakers. Like in an arena, you might need the line areas. There might be an outdoor area, like let's say a parking lot, where you might need horn speakers. You wouldn't put a line area in a parking lot, right, to make announcements. Now, zoning, you want to turn it on, turn it off. Then you have ambient noise level control. So let's say at an airport, you have 1,000 people in a particular environment, and it's crowded, right? Evening, 6 o'clock, too many people flying in, flying out. But morning, 4 a.m., not too many people. You don't want the same level of background music being played. So ambient noise level control is very, very important, and TOA manufactures ambient noise level controllers, which are excellent in different applications. Specific area coverage, yes, you want to target a specific area, you use shareable line areas, right? The SRDA in particular. Function of process equipment, so we have DSP measure, filter, all of the bells and whistles when it comes to the MS61 and the DPSP3, right? They are ideal and hot favorites for spaces like auditoriums, for gyms, for arenas, for all these applications, because they have included crossovers, EQing, signal delays, a lot of different functionalities. With the MS64, you also get iPad control, right? So you can control the output levels using just the iPad. You don't have to go every now and then to the mixer to, change the levels. And they're very, very good for sports arenas and sports complexes. This is a real world example, right? So you are evenly, like I said, you're evenly distributing the sound using the SX5 in this case. So you're covering the bleachers, you're covering the space where the game is played. Then you have wireless microphones, you have power amplifiers, you have digital mixers.